It is from section B. In section B, we have 12 questions. Out of 12, you have to write any 5 questions according to 2021-22 pattern. So, let us have a discussion. If x and y are real numbers such that 1 plus I into x minus 2i by 3 plus I plus 2 minus 3i into y plus I by 3 minus I equal to I, then determine the values of x and y. So the given complex number is, so first what you have to do, you have to simplify. What I am doing is, individual terms are there, no? Rationalizing I am doing. So first given complex number 1 plus I into x minus 2i by 3 plus I multiplying and dividing by 3 minus I plus 2 minus 3i into y plus I into 3 minus I here in the denominator. So multiplying and dividing by 3 plus I. Which is equal to I. So that implies that, so the denominator value is a plus b into a minus b, a square minus b square. So it will become 3 square minus I square. In the numerator, we need to simplify. So first the bracket value x plus ix minus 2I into 3 minus I plus here in the denominator 3 minus I into 3 plus I, 3 square minus I square. So here also 2y minus 3iy plus I into 3 plus I is equal to I. So x into 3, 3x, 3 into ix, 3ix, 3 into minus 2i, 6i, minus I into x, minus ix, minus I into I, minus I square x, minus I into minus 2i plus 2I square divided by 9 minus I square plus here also actually 3 into 2y, 6y, 3 into minus 9iy plus 3i, I into 2y plus 2iy, I into minus 3I square y plus I square divided by 9 minus I square is equal to I. Wherever I square is there, you have to replace with minus 1. I square is equal to minus 1. So 3x plus 3ix minus 6I minus ix, I square value minus 1 means minus of minus plus x minus 2 divided by 9 plus 1, I square value minus 1, no? 9 plus 1 plus 6y minus 9iy plus 3I plus 2iy, I square value minus 1, so minus of minus plus 3y minus 1 divided by 9 plus 1, which is equal to I. In both the terms in LHS, 9 plus 1 is the 10. So 10 LCM we can take into this side. So 3x plus 3ix minus 6I minus ix plus x minus 2 plus 6y minus 9iy plus 3I plus 2iy plus 3y minus 1 is equal to 10I. Now in LHS, the terms containing I, not containing I, write one side. So 3x plus x minus 2 plus 6y plus 3y minus 1. So these are the terms not containing I, plus the terms containing I am writing. So 3x minus 6 minus x, here minus 9y plus 3 plus 2y, which is equal to 10i. So that implies that 3x plus x 4x, 6y plus 3y 9y, minus 2 minus 1 minus 3, plus I into 3x minus x 2x, minus 9y plus 2y minus 7y, minus 6 plus 3 minus 3 is equal to 10i. So I is the imaginary part, real part is not there. No, we can write as 0 plus 10 into I. Comparing real parts and imaginary parts. Just I am putting here, dear students, for your convenience. So by comparing, on comparing real and imaginary parts on both sides, we get 4x plus 9y minus 3 equal to 0 and 2x minus 7y minus 3 is equal to 10. So 4x plus 9y minus 3 is equal to 0 and 2x minus 7y minus 13 equal to 0. Now on solving these equations, you will get x comma y. Solving the equations, solving the above equations. So second equation multiplying by 2. So 4x plus 9y minus 3 equal to 0. 2x minus 7y minus 13 equal to 0 is there now. So multiplying by 2 to get the same values. 4x minus 14y minus 26 is equal to 0. Multiplying by 2 here. So by subtracting, sign change, minus plus plus. These two will be cancelled. 9y plus 14y, 23y plus 26 minus 3 plus 23 equal to 0. So 23y is equal to minus 23. That implies that y is equal to minus 1. So y is equal to minus 1. Substitute in 2x minus 7y minus 13 equal to 0. So 2x minus 7 into minus 1 minus 13 equal to 0. That implies that 2x plus 7 minus 13 equal to 0. 2x minus 6 is equal to 0. So 2x is equal to 6. That implies x is equal to 3. Therefore, the values of x and y are 3 and minus 1. We'll move to the next question, dear students. Yeah, the next question, question number 17. If x plus iy equal to 1 plus 1 by 1 plus cos theta plus I sin theta, then show that 4x square minus 1 equal to 0. See here, given x plus iy is equal to 1 by 1 plus cos theta is the real part plus I into sin theta is the imaginary part. So here we are going to do that rationalizing. So 1 plus cos theta multiplying and dividing by 1 plus cos theta minus I sin theta multiplying and dividing by, so 1 plus cos theta minus I sin theta. So x plus iy is equal to 1 plus cos theta minus I sin theta divided by denominator a plus b into a minus b form is there. So a square minus b square, 1 plus cos theta whole square minus I sin theta whole square. So x plus iy is equal to 1 plus cos theta minus I sin theta divided by a plus b whole square formula, 1 plus cos square theta plus 2 cos theta I sin theta whole square. I square means minus 1. So minus sin square theta. Here I square value is minus 1. You also know that. So minus into minus is plus. One plus cos theta minus I sin theta divided by 1 plus cos square theta plus 2 cos theta plus sin square theta. Sin square theta plus cos square theta value is 1. So which is equal to 1 plus cos theta minus I sin theta divided by cos square theta plus sin square theta is 1. 1 plus 1 is 2. So 2 plus 2 cos theta, 2 take common, 1 plus cos theta. Here directly I am writing, dear students. I hope you understand that. Cos square theta plus sin square theta value is 1. 1 plus 1 is 2. 2 plus 2 cos theta. So 2 we are taking common. This is x plus iy. Now x plus iy is equal to, now this complex number in RHS we have to simplify. 1 plus cos theta divided by 2 into 1 plus cos theta minus I into sin theta divided by 2 into 1 plus cos theta. According to the result, you can go, dear students. In the question, they are asking to prove 4x square minus 1 equal to 0 or 4x square is equal to 1. They are asking to prove. So that is the reason only we are comparing on both sides real part. So x plus iy is equal to 1 by 2 minus I into sin theta divided by 2 times of 1 plus cos theta. So on comparing real parts on both sides, so x is equal to 1 by 2. Cross multiply, 2x is equal to 1. Squaring on both sides, 4x square is equal to 1. So what they are asking to prove? Minus 1. So 4x square, that 1 we can take here. Therefore 4x square minus 1 is equal to 0. Hence proved. Once again I'll scroll down the question. Slowly you can understand, your students. This is very important also. Number of times you practice, just you revise that. We'll move to the next question. The next question, question number 18, answer here. If 1 omega omega square are the cube roots of unity, then prove that. given that 1 omega square are the cube roots of unity. Whenever they are cube roots of unity, then we have 1 plus omega square is equal to 0 and omega cube is equal to 1. So these two important results you keep in mind, dear students. Next, you have to consider LHS. Now consider they are asking to prove this result as 49. 2 minus omega, 2 minus omega square, 2 minus omega power 10 into 2 minus omega power 11. See here, what I am going to do is, first here simplification. Omega power 10 can be written as omega power 9 into omega, base are equal, power should be added. Omega power 9 can be written as omega power 3 whole power 3 into omega. Omega power 3 value is 1 only, no, omega cube is equal to 1. So 1 power 3 is 1 into omega ultimately. So omega power 10 is equal to omega. Suppose in the same way, omega power 11 can be written as omega power 10 into omega only, no. So omega power 10 is omega into omega, that is equal to omega square. So therefore omega power 11 is equal to omega square. Now come to the LHS. 2 minus omega into 2 minus omega square. 2 minus, in place of omega power 10 replace with omega. 2 minus omega power 11 can be written as omega square. So here 2 minus omega twice is there now. So 2 minus omega whole square. 2 minus omega square also twice is there. So 2 minus omega square whole square, which is equal to a square b square means ab whole square we can write. So 2 minus omega into 2 minus omega square whole square. So which is equal to 2 into 2, 4. 2 into minus omega square minus 2 omega square minus 2 omega minus into minus plus omega square into omega is omega cube. We know that omega cube is equal to 1. So 4. From these two minus 2 take common. Omega square plus omega plus 1 whole square. Since 1 plus omega square is equal to 0, omega plus omega square is equal to minus 1. So in place of omega square plus omega, replace with minus 1. 4 minus 2 into minus 1 plus 1 whole square. So which is equal to 4 plus 2 plus 1 whole square. That means 7 square, which is equal to 49, which is a required RHS. So they are asking to prove this result, dear students. So slowly you can understand that. We'll move to the question number 19. The next question, find the range of the expression x plus 2 by 2x square plus 3x plus 6. To find the range of this type of functions, first you have to assume the given expression as y. So solution number 19, let y is equal to x plus 2 divided by 2x square plus 3x plus 6. Now cross multiplication. So y into 2x square plus 3x plus 6 is equal to x plus 2. So 2x square y plus 3xy plus 6y, that x plus 2 also we are taking this side, minus x minus 2 equal to 0. So first quadratic term, so x square into 2y. Next from these two x take common, 3y minus 1 plus the rest of the term 6y minus 2 equal to 0. Keep that equation number 1. This equation is a quadratic equation in x. So this you have to compare with equation 1, comparing with ax square plus bx plus c is equal to 0. Then we have the values. A is equal to 2y, b is equal to 3y minus 1, and c is equal to 6y minus 2. Since x is real, range means real only, no? Since x is real, then the discriminant of the quadratic equation should be greater than or equal to 0. That is, discriminant means b square minus 4ac is greater than or equal to 0. So b square, what is b square? 3y minus 1 whole square minus 4 into 2y into c value 6y minus 2 is greater than or equal to 0. Here a minus b whole square expansion, 9y square plus 1 minus 2 into 3y into 1, 6y, minus 8y into 6y minus 2 is greater than or equal to 0. 9y square plus 1 minus 6y minus 48y square plus 16y is greater than or equal to 0. So minus 39y square minus 48 plus 9. After that 16y minus 6y, so plus 10y plus 1 is greater than or equal to 0. So minus take common, 39y square minus 10y minus 1 is greater than or equal to 0. So if you remove this minus, inequality will change. So 39y square minus 10y minus 1 is less than or equal to 0. So factorization here, 39 into minus 1 is minus 39, minus 13 and plus 3. So 39y square minus 13y plus 3y minus 1 is less than or equal to 0. From these two, from these two. So 13y, if you take out common, 3y minus 1 plus 1 into 3y minus 1 is less than or equal to 0. So now 13y plus 1 into 3y minus 1 we are taking common. So 13 take common, here y plus 1 by 13. Here 3 take common, y minus 1 by 3. So 3 into 13 we can take this side. So y plus 1 by 13 into y minus 1 by 3 is less than or equal to 0. So y plus 1 by 3 means y minus of minus 1 by 13 into y minus 1 by 3 is less than or equal to 0. So it is in the form of x minus alpha into x minus beta. Here you need to learn the formula and the result. x minus alpha into x minus beta is less than or equal to 0. That implies that x belongs to closed interval of alpha comma beta when alpha is less than beta. So this is the formula we are going to apply. So in place of x, y is there now. So y belongs to, so according to this, y belongs to closed interval of alpha value is minus 1 by 13 comma 1 by 3. So that is the range of given expression is, so we can write like this, minus 1 by 13 is less than or equal to x plus 2 by 2x square plus 3x plus 6 is less than or equal to 1 by 3. I hope you people understand this, students. We'll move to the next question. Yeah, the question number 20. Solve x cube minus 7x square plus 14x minus 8 equal to 0 given that the roots are in geometrical progression. So geometric progression means we know that how to take the roots. First, given equation x cube minus 7x square plus 14x minus 8 equal to 0. We put that equation number 1. Given that the roots are in GP, given that the roots of equation 1 are in GP, let us consider the roots. Let the roots be AR, A by R. So GP means the roots we are taking like this, AR, A by R. After that, what we have to do? Product of the roots better to take. So here the product of the roots, we have S3 is equal to, that means the product of the roots. So S3 is equal to AR into A by R is equal to sum of the roots means minus B by A. Product of the roots taken 2 at a time is C by A. Here minus D by A. So minus of minus 8 plus 8 will come. Here R get cancelled. A into A is A cube, that is equal to 8. That also can be written as 2 cube. A cube equal to 2 cube, that implies that A is equal to 2. So A means what? This is also one of the roots now. Since A is equal to 2 is, so one of the roots of equation 1, then by synthetic division, then by using synthetic division, first x cube coefficient in the equation, x cube coefficient is 1 minus 7 14 minus 8. So 1 minus 7 14 and minus 8. So 2 is the root. So first here you have to put 0, add 1 plus 0, 1 and 0, so it will become 1. 1 into 2, 2, adding these two, minus 7 plus 2 is minus 5. Minus 5 into 2, minus 10. So here plus 4 will come, adding 14 and minus 10, 4. 4 2s are 8. So 0 will be there. So cubic equation to quadratic equation, we got it. X is equal to 2 here. X is equal to means is a factor. X is equal to 2. So equation 1 can be written as, equation 1 can be expressed as x cube minus 7x square plus 14x minus 8 is equal to, x is equal to root, already x is equal to 2 is the root, we got it. A is equal to 2 means x is equal to 2. So x minus 2 into, this is quadratic term, this is linear term, this is constant term. So for our understanding purpose, I am putting here marks, dear students. So we can write it as x square minus 5x plus 4. So even by factorization we can do that, x minus 2 into x square minus 4x minus x plus 4. So x minus 2 into x minus 4 minus 1 into x minus 4, x minus 2 into x minus 4 take common into x minus 1. So therefore this cubic equation expressing as the product of 3 factors. Therefore the factors for, we can equate to, now which is also equal to 0, polynomial only, no? Therefore x is x minus 2 equal to 0, x minus 4 equal to 0, x minus 1 is equal to 0. Therefore x is equal to 2, x is equal to 4, and x is equal to 1. So this is the way we will get the roots. Therefore the roots of the given equation, the roots of given equation are 1, 2 and 4. We'll move to the next question. The next question, number 21. Find the sum of all 4-digit numbers that can be formed using the digits 1, 2, 4, 5 and 6 without repetition. See here, first the given digits you have to write it. Given digits 1, 2, 4, 5 and 6. So total how many digits are there? 5 digits we are getting here. Therefore n is equal to 5, the number of digits. How many digits we required? Find the sum of all 4-digit numbers. Required digit. Required digit numbers. R is equal to 4. Required R is equal to 4. So R value we got it, and n value, total numbers is given as 1. So the sum of all digit numbers that can be formed using from n digits is formula we have. We have one important formula, dear students. The sum of all digit numbers that can be formed using given n numbers, given n numbers without repetition are n minus 1 p r minus 1 into sum of the digits into 1, 1, 1 and so on r times. So by using this formula, we will get it the answer. So for this, we need to add the sum of the digits. So here, sum of the digits 1 plus 2 plus 4 plus 5 plus 6. 6 plus 4, 10. 10 plus 7, 17, 18. So the remaining you can substitute in this formula and get the answer. Therefore, n value 5, 5 minus 1 p r minus 1 r value 4 into sum of the digits is 18 into how many ones r times 1, 1, 1, 1 r is equal to 4. So which is equal to 4p3 into 18 into 1, 1, 1. 4p3 means 4 into 3 into 2. So 4p3 value is 24 into 18 into 1, 1, 1, 1. So 24 into 18. 18 4s are 72. 18 2s are 36. 36 plus 7. So 43. So 432 into 1111 into, so first time if you write 432, next time 432, next time 432, again next time 432, 2 5 9, again 9 7 4. Therefore the product of these values is equal to 4,79,952, which is the required the sum of the digits. I hope you people understand, your students. For this question, we'll move on to the question number 22. Yeah, the next question, simplify 34c5 plus summation or sigma r is equal to 0 to 4, 38 minus r c4. So in the solution step, 22nd question, first you have to assume that 34c5 plus sigma r is equal to 0 to 4, 38 minus r c4, that is equal to 34c5 plus r is equal to 0. If we substitute 38c4 plus r is equal to 1, substitute 37c4 plus r is equal to 2, substitute 36c4, r is equal to 3, substitute 35c4, r is equal to 4, only till 4 here, r is equal to 0 to 4. 4 substitute 34c4. After that, this is the only turning step, dear students. Here, these first term and last term, which is connected by one important result in permutations and combinations. The combination result, one of the important and the results that I am going to write here. See, what is the result we are going to apply is NCR plus NCR minus 1 is equal to N plus 1 CR. See that the first term 34C5, 34C4 can be written as here 5 minus 1. It is in this NCR plus NCR minus 1 only, no? So we can write it as the first term and the last term can be written as N plus 1. So 34 plus 1. First time I will write it. See, R value is 5. The rest of the terms as it is. First, you have to write from the 35, 36, 37, 38. So 35 C4. Even here also you understand, no? So we can write here 35 only. It's better. So 35 C4, 36 C4, 37 C4 plus 38 C4. Again from these two, 35 C5, 35 C5 minus 1. We can write it as 36 C5 plus 36 C4 plus 37 C4 plus 38 C4. Again by using these two, again the same formula whichever I mentioned in that is equal to 37 C5 plus 37 C4 plus 38 C4, which is equal to, again by using this, 38 C5 plus 38 C4. Again by using the same formula, NCR plus NCR minus 1 equal to N plus 1 CR. Sir, you are saying from that time onwards, again the same formula, again that formula only, dear students. NCR plus NCR minus 1 is equal to N plus 1 CR. Once again I am writing. So 38 plus 1, 39. C, R value is 5. Simplified, they said, no? So we simplified and we wrote the answer. This is the required. So the next question, we'll move to that. Yeah, the next question. Resolve x square plus 5x plus 7 by x minus 3 whole cube into partial fractions. This question, in this denominator, if you observe that x minus 3 whole cube, 3 times the factor x minus 3 is repeating. Generally, if you write like this, no, so we can write the partial fractions as a by x minus 3 plus b by x minus 3 whole square plus c by x minus 3 whole cube. Instead of that method, we are going to write as the given partial fractions. You have to write it x square plus 5x plus 7 divided by x minus 3 whole cube. Here take x minus 3 is equal to some y. X in terms of y you have to write it. So y plus 3 x value. So which is equal to, in place of x substitute y plus 3 and in place of x minus 3 y. So y plus 3 whole square plus 5 into y plus 3 plus 7 divided by y cube. So numerator you have to expand. Y square plus 3 square means 9 plus 2 into y into 3. So 6y plus 5y plus 15 plus 7 divided by y cube. So first y square, 6y plus 5y is 11y plus 15 plus 7, 22. 22 plus 9, 31, divided by y cube. Now split into terms, y square by y cube plus 11y by y cube plus 31 by y cube. So which is equal to y square cancel 1 by y plus 11 by y square plus 31 by y cube. But the question in terms of x is there, you also give the answer also in terms of x. So wherever y is there, you have to replace again x minus 3. So which is equal to 1 by x minus 3 plus 11 by x minus 3 whole square plus 31 by x minus 3 whole cube. Hope you people understand now. Yeah, question number 24 is also partial fractions question, but this given fraction is improper fraction. Why? Because the degree of numerator is 3, the denominator degree is also 3. So degree of f of x is greater than or equal to degree of g of x. So the fraction is called improper fraction. It is improper fraction. X cube by x minus a into x minus b into x minus c is an improper fraction. Whenever it is improper fraction, how to write is the partial fractions. Numerator highest, and that too both the degrees are same. So x cube is the highest power in the numerator, even denominator also x cube, x into x into x is there. So numerator x cube coefficient is what? 1. Denominator x cube coefficient is also 1. Plus, like this way you can write. Suppose here 2x minus 1, 2x minus 3 and 2x minus 5 is there. So 2x into 2x into 2x, 8x cube will come now. So x cube coefficient is 8 in case. Just I am saying. But according to this question is x cube coefficient is 1. So 1 only we write it. After 1 by 1, after writing the coefficient of highest power in numerator by denominator plus the remaining we are treating as partial fractions like linear factors. Capital A by x minus a plus capital B by x minus b plus capital C by x minus c. So how to write that partial fractions? I hope you understand now. Take that LCM on both sides. X cube by x minus a into x minus b into x minus c, which is equal to so LCM is x minus a into x minus b into x minus c. So as it is, the term will come x minus a into x minus b into x minus c plus x minus a get cancelled, a into x minus b into x minus c plus capital B into x minus a into x minus c. X minus c cancel means capital C into x minus a into x minus b. So both the denominators will be cancelled. Therefore we have x cube equal to x minus a into x minus b into x minus c plus capital A into x minus b into x minus c plus capital B into x minus a into x minus c plus capital C into x minus a into x minus b. After this result, to get capital A, capital B, capital C values, put small x is equal to a in the above equation. You put that equation number 1, it is. In the equation number 1, we get x is equal to a means this side a cube. So in the first term, if you substitute x is equal to a, the total term goes to be 0. And in b and c also the term goes to be 0 except second term. So capital A into a minus b into a minus c, that implies that capital A is equal to a cube by a minus b into a minus c. Similarly, put x is equal to b in the equation 1, we get b cube equal to, so in the first term and second term and last term, in the equation 1 LHS RHS substitute, so it will becomes b into b minus a into b minus c. So from that, b is equal to b cube divided by b minus a into b minus c. So now similarly, to get c value, put x is equal to c in the above. In the equation 1, we get c cube is equal to capital C into c minus a into c minus b. So that implies that capital C equal to c cube divided by c minus a into c minus b. After getting these values, substitute in the given part here, in substitute in this capital 1. So therefore, capital A, capital B, capital C values substitute in capital 1. So x cube by x minus a into x minus b into x minus c is equal to 1 plus, see here, a by x minus a. So a value is what? A cube by a minus b into a minus c into x minus a. Similarly, b value, b cube by b minus a into b minus c into x minus b, plus c value, c cube divided by c minus a into c minus b into x minus c. I hope you people understand. We'll move on to the next question. Yeah, in this question number 25, resolve 2x plus 3 by x minus 1 whole cube into partial fractions. First, given for fractional function, that is 2x plus 3 divided by x minus 1 whole cube. So it is like 23rd problem which we discussed in this session. Take x minus 1 is equal to y. So x is equal to y plus 1. So wherever x is there, replace with y plus 1 by y cube. So which is equal to 2y plus 2 plus 3 divided by y cube. So 2y plus 5 divided by y cube. If you don't want to do this method, you can do that as a by x minus 1 plus b by x minus 1 whole square plus c by x minus 1 whole cube, and then general procedure we can do that. So this can be done as a 2y by y cube plus 5 by y cube. So one of the y cancel here, y square terms, 2 by y square plus 5 by y cube. Sir, in general method, if you go like y term also, that means x minus 1 also will come in, that value goes to be 0. That is the reason we are not getting. So 2 by y minus 1, y means what? X minus 1 whole square plus 5 by x minus 1 whole cube. Therefore 2x plus 3 by x minus 1 whole cube. I hope you understand now. Yeah, question number 26. A and B are events with P of A equal to 0.5 and P of B is equal to 0.4 and P of A intersection B equal to 0.3. So given that A and B are any two events or two events, the probability of A, P of A is given as 0.5 and probability of the event B is given 0.4 and P of A intersection B is also given 0.3. Find the probability that the first question A does not occur. The probability of A does not occur. That means probability of A complement, that is P of A complement or A bar also we can write. So P of A complement is equal to 1 minus P of A, that is equal to 1 minus P of A value, how much it is given, 0.5, that is equal to 0.5. Therefore P of A complement is equal to 0.5. Next, neither A nor B occurs. So second one, the probability of neither A nor B occurs. That is P of A union B whole complement, or we can write as from De Morgan laws, if you apply P of A complement intersection B complement also we can write. Otherwise we can write, this is easy. P of A union B whole complement, neither nor. That means 1 minus P of either or. So either or means A union B, probability, addition theorem of probability. 1 minus P of A union B. P of A union B not there, no? But by using addition theorem, 1 minus P of A union B means P of A plus P of B minus P of A intersection B. So which is equal to 1 minus P of A value 0.5, P of B 0.4 minus P of A intersection B is 0.3. 1 minus 0.5 plus 0.4, 0.9 minus 0.3, which is equal to 1 minus 0.9, 0.3 is 0.6, which is equal to 0.4. Therefore, P of A union B complement is equal to 0.4. After that, the last question in this question paper, we have that multiplication theorem. So last question, state and prove the multiplication theorem on probability. So very important, here 4 marks question, sometimes we may expect for 4 marks also. So question number 27. So in that question number 27, state and prove is given. No, statement I am writing here. Statement. Next proof. We'll give that 2 lines. We'll write with a different pen. So what is the statement of multiplication theorem? If A and B are any 2 events or simply 2 events of a random experiment such that P of A is not equal to 0 and P of B is also not equal to 0, then P of A intersection B is equal to P of A into P of B given A, or P of B by A, which is also equal to P of B into P of A given B. This is the statement of multiplication theorem on probability. Now we will do the proof of this one. So from, anyway you write that again the events and all statement. A comma B are 2 events of a random experiment by definition of condition probability. So 2 definitions we have. One is P of B given A can be defined as P of B intersection A by P of A, provided that P of A should not be equal to 0. So cross multiply P of A intersection B or B intersection A, both are same. So P of B intersection A is equal to P of A into P of B given A. Equation number 1. Again by another definition. From another definition, P of and P of A given B is equal to P of A intersection B by P of B. So P of B is not equal to 0. So cross multiply P of A intersection B is equal to P of B into P of A given B. So from 1 and 2, P of A intersection B is equal to P of A into P of B given A, that is also equal to P of B into P of B given, A given B. So hence the theorem. Yeah, this is the way we can do that. The multiplication or multiplicative theorem on probability, dear students. I hope you people understand. Next we will move to the section C.